Hello students. In the last class we have completed the construction and working of standard hydrogen electrode along with determination of electrode potential of various electrodes. And in the previous literatures we have used some of the electrode potential values. For example, the electrode potential of zinc electrode Zn2 plus par Zn. Zinc electrode, zinc reduction potential of zinc. What is the value? Its value is minus 0.76 volt. Electrode potential of copper values Cu plus 2 bar Cu. Its value is 0.34. Electrode potential of aluminium is minus 1.66. Inert of magnesium, reduction potential of magnesium is minus 2.37. Magnesium is 2.37. Electrode potential of silver couple is 0.80. Electrode potential of iron is minus 0.44. Just some of the values I have mentioned here. So these are the different electrodes which having a different tendency to undergo reductions. These are the reduction potentials, or we can write oxidation potential, generally electrode potential. Based upon these values we are going to predict whether it undergoing oxidation or a reduction. Now different electrode having different tendencies to undergo reduction. When these electrodes, when it is arranged in the increasing or decreasing order of these values, electrode potential values, it forms a series. That series we can call electrochemical series. So now in this class we are moving to learn a new concept, that is electrochemical series. So what is the definition of electrochemical series? Now let us study the next concept, electrochemical series. Now what is meant by this electrochemical series? Simple definition, electrochemical series is nothing but it is just an arrangement of various elements or electrodes in the order of increasing or decreasing values of their SRP, that is standard reduction potential. That is known as electrochemical series. Just it is an arrangement of different electrodes in the increasing or decreasing order of its potential values. It is we can call the electrochemical series. And this electrochemical series which finds many applications. For example, so by knowing the value of electrode potential of a metal, we can predict or we can compare the reactivity of metal. Which electrode is a strong oxidizing agent or a reducing agent among the given species also we can predict. And in order to predict the feasibility of a reaction, they will provide two reactions. Which reactions is feasible or not? Which one is feasible, which one is not feasible? Possibility, whether the given reaction is possible or feasible. Both the words same, feasibility of a reaction. Whether the reaction is possible in that direction or not we can predict. And by knowing the value of electrode potential we can calculate the cell potential or EMF to predict whether the metal can liberate hydrogen gas or not from an acidic solution when dipped in it. We can predict this also, and to find the maximum work done by the cell by knowing the standard electrode potential of an electrode. Now we will discuss about these applications. These are the very important applications. Based upon this concept we can apply this concept to solve the many objective problems. Now let's move to the next, the first application. So in this class, one more time I am repeating, in this class particularly we are dealing with electrochemical series and its application. A small concept, electrochemical series and application. Concept small but important. Now let us consider the first one, applications. The first application is फर्स्ट वन क्या है? फर्स्ट वन टू कंपेयर द रिएक्टिविटी. फर्स्ट एप्लीकेशन टू कंपेयर the activity of electrode, or we can call it to compare the activity or reactivity of electrode or metals. So how we are going to compare the activities or reactivity? तो यहाँ पर in this case suppose in general point I am going to consider in general, for example, let us consider two metals, or we can call electrode A and B, whose SRP values, E0 value of this E0 value of the electrode A is given as, assume in general values I am considering. Suppose its value is 2.3, its value is 2.37, or this for element B its value is 1.37, or just its value is 2, its value is 1, 4, 1, 2, 10, x, y, z. So we are going to consider some x, y and z. For element or for electrode C its value is 0.37, something values I have considered among these. So which one is more reactive among this? So how we are going to predict that? Reactivity, more reactive, which one is oxidizing agent and which one is a reducing agent, to predict the reactivity. So here in simple way, the electrode with its higher potential values which undergo, electrode which having high value, higher the SRP, high value of SRP, this undergo reduction. The substance which undergo reduction is known as oxidizing agent. So oxidizing agent. Among these three elements, A is a strong oxidizing agent. Look at this. By knowing these three values, you can compare these values. Among these three, this value is higher, largest value. So therefore, the electrode which having higher SRP is a strong oxidizing agent. So we can arrange these three electrode in the increasing or decreasing order of their oxidizing potential or reducing potential, oxidizing tendency or reducing tendency, oxidizing strength or reducing strength. So here we can predict based upon this concept. Now, so we can predict the first application to compare the reactivity. The electrode potential. So here it is oxidizing agent. Now reducing agent. Among these three, C is reducing agent because smaller the value of its reduction potential, high value of SRP, higher the SRP undergoing reduction. Lower the value of reduction potential, ये कम है यहाँ पर, this undergoing, यहाँ पर reduction हुआ तो this undergoing oxidation, the substance which undergo oxidation is called as reducing agent. It's opposite to this concept. So here C is reducing agent and B is oxidizing agent. By comparing the two electrode, we can predict oxidizing and reducing strength. This is the first one. Now the second, let's move to the second application to predict feasibility of a reaction. Second concept, feasibility of reaction. Feasibility of a reaction. How we are going to predict the feasibility of a reaction? So first I will consider a simple example that is well-known reaction, simple reaction. Zinc Zn plus Cu2 plus, which gives rise to Zn2 plus plus Cu. This is one reaction, and the second reaction is Zn2 plus Cu gives rise to copper ion plus zinc. So among these two reactions, which reaction is feasible in the given direction? You can predict ये दोनों में कौन सा रिएक्शन पॉसिबल है, कौन सा रिएक्शन नहीं है. So among these two, which reaction is feasible and which one is not feasible? Yes, of course, you can predict among these two. You are going to select the first one is feasible reaction, whereas the second one is not. This reaction is not possible in this direction. Correct? Because in the first reaction, zinc is more reactive than copper. Therefore, zinc can displace the metal from less reactive compounds. तो जिंक अंडरगोइंग ऑक्सीडेशन इन दिस केस, ये क्या हो रहा है यहाँ पर, जिंक अंडरगोइंग ऑक्सीडेशन, whereas copper undergoing reduction, copper undergoing reduction. Whereas in this case, zinc undergoing reduction, copper undergoing oxidation. Copper क्या हो रहा है यहाँ पर, copper oxidation, copper undergoing oxidation. So this one is reactive because in 10th class you have studied the reactivity series. Reactivity series. I have explained how to remember the reactivity series by telling a story in Kannada. That is, ಕನಕನ ಮಗಳು ಜಿಮ್ಮಿಗೆ ಹೋಗಿ ಐರನ್ ರಾಡ್ನ ತಕೊಂಡು LED ಬಲ್ಬ್ನ ಹಾಕ್ತಾಳೆ. ಅಲ್ಲಿಂದ ಕಮರ್ಷಿಯಲ್ ಆಗಿ ಗೋಲ್ಡ್ ಅಂಡ್ ಪ್ಲಾಟಿನಮ್ನ ತಗೊಂಡು ಹೋಗ್ತಾಳೆ. ಸೊ ದಟ್ ಮೀನ್ಸ್ ಕನಕನ ಸೋಡಿಯಂ ಕನಕನ ಮಗಳು MgAl, ಕನಕನ ಮಗಳು ಜಿಮ್ಮಿಗೆ ಹೋಗಿ ಐರನ್ ರಾಡ್ನ ತಗೊಂಡು LED ಬಲ್ಬ್ನ ಹಾಕ್ತಾಳೆ. potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead and hydrogen. Reactivity series that you have studied in 10th class, and you have you know the different tricks to remember this reactivity series in your own language. So this is the reactivity series. After this, after the hydrogen, ಕನಕನ ಮಗಳು ಜಿಮ್ಮಿಗೆ ಹೋಗಿ ಐರನ್ ರಾಡ್ ತಗೊಂಡು LED ಬಲ್ಬ್ನ ಹಾಕಿ ಕಮರ್ಷಿಯಲ್ ಕಾಪರ್, mercury, silver, commercial agi gold and platinum. So by remembering that it is a story, so based upon the story we have created this reactivity series. So here you know that since zinc is more reactive than copper ये जो हाइड्रोजन के ऊपर जो है, these are more reactive, this is more reactive, and down the group reactivity decreases. Since zinc is more reactive, it can displace copper from its solution. Therefore, first reaction is feasible, whereas second one is not feasible. So based upon this, you are going to predict. Suppose in general, suppose, or else one more reaction, redox reaction that you have studied in the previous classes. Lead oxide plus copper gives rise to copper oxide plus lead. This is one reaction, and reverse reaction, that is copper oxide plus lead gives rise to lead oxide plus copper. Which reaction is feasible among these two? देखिए कौन सा reaction feasible होता है यहाँ पर, 100%. Reactivity series देखिए यहाँ पर lead is present above the series, above the hydrogen, whereas copper is present below. Copper is less reactive, lead is more reactive. So therefore, lead undergoing oxidation, copper undergoing reduction. This one is feasible and this is not feasible reaction. So these are the general reaction. Feasibility of a reaction we can predict based upon reactivity series. Now, based upon the electrochemical series, how we are going to predict the reaction? How we are going to predict the reaction? Now I am going to consider as general reaction. General reaction, that is A is an element plus A plus B to the power n plus, means B is an ion, A is an electrode. When it react with this, which gives rise to A to the power n plus element B. So this is one reaction. Now the second reaction, that is reverse reaction, I am going to consider A ion, An plus, A ion when it react with the electrode B, this gives rise to A plus B n plus. Two reactions are there, reaction number 1 and reaction number 2. In these two reactions, Now I am providing the electrode potential values. Reduction potential of electrode A is given. Similarly, reduction potential values of B is also it is given. What is the reduction potential? Now I am considering two values. Suppose if this electrode potential values of A is 4, B is 2. General values I have given. That means for one electrode its value is high and other electrode its value is low. These are the reduction potential values. Now based upon these values, can you predict which reaction is feasible among these two? Because I have not mentioned any metal in this case. General, any electrode if it is given, two reactions they have given, which reaction is feasible and what is the net reaction? By comparing these, or else just first point, you predict which reaction is feasible among these two. We'll discuss the problems, net reactions and all. Now, look at this. In the first case, what happened? In first case, consider the element A. Element A undergoing oxidation or reduction. Element A, oxidation state is 0. 0, in this case, it is plus N, either 1, 1 plus, 2 plus, 3 plus, etc. Depend upon the reaction. So that means here is a loss of electron. That means this undergoing oxidation. Element A undergoing oxidation in the first reaction and A undergoing reduction in the second reaction. One element I have compared. Now come to this point. Now as you know that higher the values of SRP, higher the values of SRP, higher value of SRP, which undergo reduction, and which is an oxidizing agent, right? Higher the SRP, undergoing reduction. You know that concept. So among these two electrode, which value is higher? 4. 4 is higher. That means reduction potential of A is greater than B. That means among A and B electrode, A having higher tendency to undergo reduction than B. So therefore, A must and should undergo reduction and B undergo oxidation. जिसका रिडक्शन पोटेंशियल वैल्यूज ज्यादा है वो कंपलसरी रिडक्शन ही होना चाहिए. ऑक्सीडेशन हुआ तो वो गलत. सो देयरफॉर इन दिस केस रिडक्शन पोटेंशियल वैल्यूज ऑफ A is higher. So therefore A should undergo reduction, and that A undergoing reduction in the second equation, therefore equation number 2 is feasible and the first equation is not feasible. This is the second application of electrochemical series. So in a given reactions, a number of reactions is given, we can predict the feasibility of reactions. Okay, now next we'll move to the third applications. What is the third applications? Third application is to calculate EMF of the cell. Third application to calculate the EMF of cell. Okay, and already we have solved many problems on this. Calculate EMF to find EMF of cell, to calculate the EMF of cell. So anyhow we have the formula. No need to discuss about this because already we have completed this concept. E naught cell is equals to E right minus E left. E right minus E left. That means reduction potential of SRP of cathode, standard reduction potential of cathode minus standard reduction potential of anode. Anode and cathode, both the values are expressed, electrode potential values are expressed in reduction potential only, right? Suppose if SRP reduction potential के जगह oxidation potential values दिया तो now standard reduction potential of cathode, now I am changing this SRP into SOP, so plus because sign changes. SOP, standard oxidation potential of anode, or else we can change in terms of SOP, standard oxidation potential of anode minus standard oxidation potential of cathode also we can write. These are the different forms. Usually electrode potential is restricted to reduction potential only, that we know that already. Whenever we are using the term electrode potential, that means it is an reduction potential values only. If they mention SOP and other one is SRP, in order to solve the objective problems easily, you need to know about these concepts. Or else anyhow, if they are given SOP, you can convert into SRP by changing the sign, and as usual same formula you can use. Or else directly you can add oxidation potential plus reduction potential. When you are adding both these two, one is oxidation potential plus reduction potential, that gives rise to E cell. If both the SOPs are given, then first anode half minus cathode half lena padega aapko. So thereby we can find the EMF of the cell. This is the third application. Now the fourth application is also an important one, to predict whether the gas liberate hydrogen or not. Let us recall the reactivity series once again. Reactivity series, the third applications हम किए थे to compare the reactivity of metal. This is the reactivity series. Am I right? Look at this. These are active metals. How we are going to define the metal? From 8th class onwards we are defining the metals. So what is meant by metal? In different way. When one definition is the substance. Usually metals is nothing but these are the elements which have a tendency to give the electron. Electron donors are called as metal. Electron acceptor are called as non-metals. देखिए यहाँ पर metals, all the active metals, these metals have a tendency to give the electrons. That means these are more reactive. Or in the reactivity series, the element present above the hydrogen have high tendency to undergo oxidation. These elements have high tendency to undergo oxidation, whereas below the hydrogen, these are the elements which having a tendency to undergo reduction. Now in terms of SRP values, reduction potential of hydrogen is arbitrarily taken as 0. Its value is 0, and above this electrode potential values is minus, whereas for these elements electrode potential values, that is reduction potential value, is plus. So in simple way we can predict if the element which having negative potential, negative electrode potential, negative reduction potential. देखिए electrode potential is nothing but the word is restricted to reduction potential only. अगर reduction potential का values minus रहा तो then these elements have a tendency to liberate hydrogen gas. If the element which having positive values of SRP, then it do not have a tendency to liberate hydrogen gas. How? Let us explain that concept. Whether the metal have a tendency to liberate hydrogen gas or not. That means the fourth application is to predict whether the metal, whether the electrode can liberate, whether the electrode can liberate hydrogen gas, whether the electrode can liberate hydrogen gas or not from acidic solution. Okay, from acidic solution. So here let us take one example. I have considered 3 beakers, beaker number 1, beaker number 2 and beaker number 3. Same 3 beakers are, you can consider, let us take hydrochloric acid HCl in these three different beakers. Here I have taken HCl. In both the case, the acid HCl is taken. That means which containing H plus ion. Now, in the first case, an electrode A is dipped in this case. Electrode A, electrode B, electrode C. A, B, C. I have not mentioned which electrode it is. If it is mentioned, you can directly predict. Suppose in generally I am mentioning this. So this one is zinc and it is copper and it is lead. Now, what is the order of, or arrange these metal in the order of liberation of hydrogen gas from the solution? Of course, zinc is more reactive, so more amount of hydrogen gas is liberated from this solution. Copper is less reactive and it is lies below the hydrogen, therefore it cannot liberate hydrogen gas. Whereas in this case, lead also liberate hydrogen gas, but it is less than zinc. So first one is zinc, lead and copper. So in general, electrode A, electrode B, electrode C. Different electrode, any electrode A, B, C, I have mentioned A, B, C. Okay, once again come back. So here, zinc, copper, lead. So how? Zinc, electrode potential values of zinc, already you know that. So electrode potential of zinc, Zn bar, its value is minus 0.76. Whereas hydrogen reduction potential H bar, H2 gas, its value is 0. देखिए यहाँ पर in the first case, in first beaker, higher the value of reduction potential undergoing reduction. That means in दोनों values में इसका value ज़्यादा है. The value 0 is greater than minus 0.76. या नेगेटिव में है तो इससे भी ज़्यादा है ये values. So therefore this undergoing reduction, ये reductions हो रहे. Reduction means H plus electron gives rise to H2. 2H plus equation balance किया मैंने यहाँ पर. तो ये जो इलेक्ट्रॉन कहां से आ रही है? फ्रॉम वेयर दिस इलेक्ट्रॉन कम्स, बिकॉज दिस मस्ट एंड शुड अंडरगो रिडक्शन. सो फ्रॉम वेयर दिस इलेक्ट्रॉन्स आर कमिंग? सो दिस इलेक्ट्रोड अंडरगोइंग ऑक्सीडेशन. सो जिंक undergo oxidation, Zn2 plus 2 electron. These electrons are used by H plus ion to liberate hydrogen gas. So therefore in this beaker hydrogen gas is liberated. Okay, right. Now in the second beaker, similarly lead undergoing oxidation, यहाँ पर भी hydrogen gas liberate होता है. Whereas in case of copper reduction potential value is 0.34, whereas electrode potential values of hydrogen reduction potential is equal to 0. So among these two, 0.34 is greater than this. So this undergoing reduction, Cu plus 2 undergo reduction, 2 electron gives rise to copper. So here hydrogen gas, it should undergo oxidation to give H plus electron. So here यहाँ पर H plus ion hydrogen gas is required. It is utilizing here. In this case, hydrogen gas is not liberated in the second beaker. Similarly, you can consider any electrode in this place. In place of zinc and copper, you can choose any electrode A, B, C, D, etc. If the electrode potential value is greater than 0, if the electrode potential value is greater than 0, in that case hydrogen gas is not liberated. If the electrode potential is negative, in that case hydrogen gas can be liberated. Now I have a question. Suppose in these beakers, in these beaker, if I use zinc and lead, only two options are given. So in which case hydrogen gas is liberated? In both the case hydrogen gas is liberated. In which case more amount of hydrogen gas is liberated? That depends upon its reactivity. Smaller the value of SRP, high tendency to liberate hydrogen gas. This is the smaller values. तो यहाँ पर liberate हो रहे, hydrogen gas is liberated. So in the electrochemical series, SRP values जितना कम होते हैं उतना amount of hydrogen gas liberate होते हैं यहाँ पर. So this is to predict whether the electrode can liberate hydrogen gas from the acidic solution or not. So in order to liberate hydrogen gas from its solution, the electrode must have negative potential, negative SRP रहना चाहिए, negative SRP. Greater the value of negative SRP, greater negative, that means smaller values, जितना values कम होते उतना hydrogen gas liberate होते. In simple way, you can remember, in order to liberate hydrogen gas, the electrode should have less SRP values. That means negative values. 0 से भी कम रहना चाहिए. Then only it can liberate hydrogen gas from the acidic solution. And the last application is, it helps to calculate maximum work done. So यहाँ पर this is also an important equations. This equations in the application part in thermodynamics, last concept में application part में हम study किए थे, and this equation is also we have given in that topic itself. Maximum work, that means free energy delta G, this is given by the formula minus NF into E naught of the cell, E naught values. So by knowing this E naught values, E naught of the cell, तो सेल का वैल्यूज आने के लिए आपको इलेक्ट्रोड पोटेंशियल चाहिए. बाय नोइंग द इलेक्ट्रोड पोटेंशियल वैल्यूज यू कैन प्रेडिक्ट E naught of the cell potential फाइंड आउट कर सकते हैं. एंड बाय दिस you can find the number of electrons, where N is the number of electrons involved in the reaction. F is Faraday constant. This value is F is a Faraday constant. It is 96500 coulomb, 96,500 coulomb. It is constant. E naught cell, that means cell potential. So this is maximum work done by the system that can be calculated by using this formula. It gives free energy. Once again, we are going to study about this in the next classes. In the upcoming class, we are going to discuss about this formula again. So these are the applications of electrochemical series. So देखिए एक बार electrochemical series. It is just arrangement of various electrode in the increasing or decreasing order of their standard reduction potential values is called electrochemical series. How it is useful? It is used to compare the reactivity. So in reactivity, the electrode with higher SRP values is strong oxidizing agent, whereas lower value is strong reducing agent. Strong oxidizing and strong reducing agent. And second application, to predict the feasibility. So in order to predict the feasibility, the electrode with higher SRP must and should undergo reduction, then only the reaction is said to be feasible. जिस electrode का SRP value ज़्यादा है वही reduction होना चाहिए. If that element undergoing oxidation, then that reaction is not feasible. Here A का values ज़्यादा है, that A must and should undergo reduction, and this is given in the second reaction, therefore second reaction is feasible. But in the first case, A undergoing oxidation, therefore this reaction is not feasible. To find the EMF on this applications, we have already solved the problems, and the last one is to predict whether the electrodes have a tendency to liberate hydrogen gas or not. So यहाँ पर simple है, if the electrode having negative SRP values, then it can liberate the hydrogen gas from its acidic solution. And last one, to determine or to calculate maximum work done by the electrode. So that is given, that is the cell. Delta Z is equal to minus NF E naught. These are the application. And on this concept, I will upload the problems, or else you can directly solve the problems on applications of electrochemical series. If you have any doubt, we'll discuss in the next class.